Bismillahirrahmanirrahim. Welcome to my channel. Chapter number 1, lecture number 6, grade 9 chemistry. Today we shall discuss relative atomic mass. Relative atomic mass is often confused with average atomic mass and mass number. Mass number, as we discussed in our previous lecture, is the sum of number of proton and neutron inside the nucleus, and can be better represented by A is equal to Z plus N. Whereas average atomic mass and relative atomic mass are the same thing. There is a huge difference. When we calculate average atomic mass, we are forced to do so because for one single atom we have sometimes 2 isotopes and sometimes 3 isotopes and maybe 4 isotopes. Especially in the case of hydrogen, we have 3 isotopes: hydrogen protium, hydrogen deuterium, and tritium. Isotopes will be discussed in the coming lectures in detail. Here we can say that the same atom of the element, you see, in all the cases, hydrogen, hydrogen, hydrogen. I better should write that as, sorry for that. A brief definition of isotope is the same atomic number for the same atoms of elements. If the element is the same, it is not another element. It is not helium, not lithium, not boron, not carbon. The same element having the same atoms, hydrogen, with the same atomic number. The only difference is due to proton and neutron. One proton, one neutron, one proton, 2 neutron. So they are called isotopes. So how can we calculate the average weight of average atomic mass of these isotopes? Because we are to fix atomic mass, a relative atomic mass, we will have to take one and the average atomic mass depending on the abundance of these atoms in the sample that we shall report. A procedure is simple. Average atomic mass means arithmetic means to take the average. A simple average means that if you have A is equal to 2 and B is equal to 3, C will be A plus B divided by 2, because there are 2, 1, 2. So in this case we get 2 plus 3 divided by 2 is equal to 2.5. That is, the average of 2 and 3 is 2.5. A similar average can be calculated for hydrogen isotopes as well as for chlorine isotopes. Chlorine has 2 isotopes, chlorine 35 and chlorine 37, with the same atomic number 17. But their existence in nature is different. Chlorine 35 is present 75% in the nature. Chlorine 37 is present to the extent of 25% in the nature. That is, out of 4, 3 part chlorine 35 is present and 1 part chlorine 37 is present. Out of 4, 3 part chlorine 35 is present and chlorine 37 is present, 1 part. Similarly, the hydrogen 1 is present, I think, although it is a supposed data from my own self, but It varies depending on the country, place, from source from here we can cut the sample. Here the average atomic mass for hydrogen can be calculated as atomic mass 1 into its percentage, which is 993 out of 1000. 993 out of 100 plus deuterium, which is present to the extent of 2 into 6 out of 1000, sorry, plus 3 into 1 divided by 1000. Look again. It is the atomic mass of protium, atomic mass of deuterium, atomic mass of tritium. Protium is present 993 atoms. That is, if we take 1000 atoms, of all the 3 hydrogens, you will get 993 atoms of protium, 6 atoms of deuterium, and 1 atom of tritium. It means that tritium is very rarely present. Very small amount of tritium is present if you take 1000 atoms. So if we calculate this average, we get 1.008. And there are the percentages. Here the percentage of, in this case, will be 99.3%, here 0.6%, and here 0.1%. So we get 1.008. This is average weight of hydrogen. So in this average weight, we have included protium 1, deuterium 2, and similarly tritium 3. This average mass shows an average atomic mass of hydrogen. So in the periodic table, you will follow or you will see hydrogen atomic mass is 1.008. So all the weights that you have got in the periodic table have been calculated in this way. Now we come to the relative atomic mass. Relative atomic mass is the same thing as average atomic mass. The only confusion that most of the people, most of the chemists, teachers and students together think about this a different thing. It's not good and it's not correct. Relative atomic mass is the same thing. It is relative atomic mass because in case of carbon we have 3 isotopes: 12, carbon 6, carbon 12, carbon 13, carbon 14. These are the 3 different isotopes of carbon. It is not exactly 13 and it is not exactly 14. And just like you see hydrogen, in case of hydrogen, they are not exact masses. The only exact mass that we get is for carbon 12 or carbon isotope 12. What means by 12? 12.000. Only in case of carbon 12, we have an exact 12. That means that there is no other fraction after decimal point. So by the scientists, although before 60s or in the 60s, scientists had used atomic hydrogen as a standard. Then oxygen is a standard. In 1960s, scientists use to compare the weights of all other atoms to hydrogen and oxygen. But later on, when they found that we can find a standard weight of carbon, which is no fraction after decimal point, was considered as standard atomic mass. So what is relative atomic mass? Relative atomic mass is any mass. Any mass means any mass of hydrogen, oxygen, carbon itself, nitrogen, sulfur, phosphorus. When we calculate it, when we determine it, compared to carbon isotope 6-12.00, the mass of any other atom, oxygen, carbon, hydrogen, nitrogen, any atom, which is obtained by comparison to carbon isotope 12. What is the meaning of comparison? When you put things on a scale, you are comparing things. For example, if you take here oxygen atoms and here carbon isotope 12, you need to take, they are to be supposed similar, they are carbon atoms, 4 carbon, and here you take 3 oxygen atoms. It is not 30, it is 3O, 3 oxygen atom, 4 carbon atom. You have compared them. When you put 4 carbon atom, isotopes of carbon 12.00, and take or put 3 oxygen atom in the other part of the scale, they become equal. When they become equal, what will be the mass of one oxygen atom? Can you analyze? Since 4 into 12, we get 48. So 3 oxygen atom must also be equal to 48, or 1 oxygen atom should be equal to 48 divided by 3 is equal to 16. Once more, the atomic mass of another atom compared to the atomic mass of carbon isotope 12, which is 12.000, is called relative atomic mass. Comparison means when we take 4 atoms of carbon and put it in the pan of a scale and compare it to require how much atom of oxygen in the other pan, we see that when we weigh them, when we compare them, we get 3 atoms of oxygen. So when 4 atoms of carbon, which is equal to 48, is compared to 3 atoms of oxygen, they will also be 48. Because this side and this side are no balance. They are equal. When they are equal, 4 atoms into 12 is equal to 48. Similarly, 3 atoms of oxygen will be also equal to 48. 1 atom will become 16. So, by comparison with 12, the weight of oxygen becomes 16. How much? 16. So this 16 is the relative atomic mass of oxygen. Similarly, you can put instead of oxygen hydrogen. Similarly, you can take other atom, for example, nitrogen, sulfur, phosphorus, and any atom whose weight is obtained by comparison with carbon 12.000, we get a relative atomic mass. Thanks for watching.